In this section, we'll be talking about what is computer programming. Computer programming is the process of designing, writing, testing, and maintaining the source code that makes up computer programs. Think of it as giving a clear set of instructions to a computer, telling it how to perform a particular task. These tasks can range from simpler ones, like adding two numbers together, to more complex ones, like running an entire online shopping platform. At its core, programming involves a series of steps. First, you design program by planning out what it would do and how it will do. Next, you write the code that will carry out those plans. And after that, you test the program to make sure it's completely working. Finally, you maintain the program over time, fixing bugs and adding new features such as needed. Now, let's talk about the basics of programming. Before you write a program, you need to understand a few key concepts. First is variables. Variables are like containers that hold data. They store values such as numbers or text that your program can use. For example, if you're writing a program that calculates the area of a rectangle, you might have variables for length and width of the rectangle. Next comes the operators. Operators are symbols that perform operations on variables. For instance, you might use the plus operator to add two numbers together, or the double equivalent operator to compare two values and see if they are equal. And lastly, the control structures. Control structures direct the flow of your program. They include statements like if-else conditions, which allow your program to make decisions, and loops, which let your program repeat certain actions until a condition is met. If we talk about programming languages, so there are four types. To write a program, you need to use a programming language. There are many different programming languages, such as its strength and weakness. First comes high-level languages. High-level languages like Python, Java, C++, and more are closer to human language. They are designed to be easy for people to read and write, which makes them a good choice for most programming tasks. Next comes the low-level languages. Low-level languages, like assembly language, are closer to machine code that computers understand. They are more difficult for people to work with, but they give you more control over how the computer operates. Next comes interpreted versus compiled languages. Programming languages can also be classified as interpreted or compiled. Interpreted languages, like Python, are executed line by interpreter. Compiled languages like C++ are translated into machine code by a compiler before they're run. And lastly, general purpose versus domain-specific languages. Some programming languages are general purpose, meaning they can be used for different types of tasks. Others are domain-specific, meaning they are designed for a specific type of work. For example, SQL is a domain-specific language that's used for managing databases. Next comes algorithms and data structures. Two of the most important concepts in programming are algorithms and data structures. An algorithm is a step-by-step procedure for solving a problem. For example, if you're writing a program to sort a list of numbers, you will need to use a sorting algorithm. Data structures are always a way of organizing and storing data in your program. Common data structures include arrays, which store data in a list, and linked lists, which store data in a chain of connected nodes. If we talk about efficiency, when working with algorithms and data structures, it's important to consider efficiency. This involves analyzing the time and space complexity of your code to make sure it runs as quickly and uses as little memory as possible. Moving on to object-oriented programming. It is a programming paradigm that's based on the concepts of objects, which are instances of classes. If we talk about classes, a class is a blueprint for creating objects. It defines the properties and behaviors that the objects will have. For example, you might have a class called car that defines properties like color and speed, and behaviors like drive and stop. Moving on to inheritance. It allows one class to inherit properties and behaviors from another class. This helps you avoid duplicating code. For instance, if you have a vehicle class, you could create a car class that inherits from vehicle, automatically getting all the properties and behaviors of a vehicle. Next comes encapsulation. It is the practice of hiding the internal details of an object. and exposing only the necessary parts. This helps you protect the data inside your objects and keep your code more organized. And lastly, polymorphism. Polymorphism allows objects to take on many forms. This means that the method in a class can perform different actions depending on the object it's called on. Let's move on to web development. Programming is also a key part of web development, which involves creating websites and web applications. Starting with HTML. HTML or Hypertext Markup Language is the standard language used to create web pages. It defines the structure of the page, including elements like headings, paragraphs, and links. CSS or Cascading Style Sheets is used to control the presentation of web pages. With CSS, you can define the color, fonts, and layouts of your pages to make them look the way you want. In JavaScript, it is the programming language that adds interactivity and dynamic behavior to your web pages. With JavaScript, you can create things like animations, form validations, and interactive maps. Back-end development involves working with server-side technologies like PHP, Ruby on Rails, and Node.js. The backend is where your application stores data, processes requests, and interacts with other systems. Let's move on to mobile app development. Mobile app development is another area where programming is essential. It involves creating applications for mobile devices like smartphones and tablets. First, let's talk about the design. The first step in mobile app development is designing the user interface, known as UI, and user experience, known as UX. This involves creating a layout that is easy to use and visually appealing. Second step is development. Once the design is complete, the next step is the development process. This involves writing the code that makes the app work. Depending on the platform you're developing for, you might use languages like Swift for iOS or Kotlin for Android. Third is testing. It is a crucial part of mobile app development. It involves running the apps on different devices to make sure it works as expected and fixing any bugs that are found. And lastly, deployment. Finally, the app is deployed by submitting it to app stores like the Apple App Store or Google Play. Once approved, users can download and install the app on their devices. If we talk about game development, it is a specialized area of programming that involves creating video games. Let's talk about game engines. A game engine is a software framework that provides the tools and libraries you need to create a game. Popular game engines include Unity and Unreal engines. If we talk about programming languages, common programming languages used in game development are C++, C#, and Python. These languages are used to write the code that controls the game's logic and mechanics. In addition to coding, game development involves creating assets like 2D and 3D graphics, audios, and animations. These assets are used to create the visual and auditory elements of the game. Game mechanics define the rules, interactions, and behaviors that make a game fun to play. This includes things like how characters move, how points are scored, and how levels are completed. Moving on to artificial intelligence and machine learning. AI and machine learning are cutting-edge areas of programming that involves creating systems that can learn and make decisions. Machine learning is a type of AI that allows computers to learn from data without explicitly programmed. It's used in applications like recommendation systems, image recognition, and autonomous vehicles. Neural networks are a key technology in machine learning. They consist of interconnected nodes or neurons that mimic the human brain. Neural networks are used to recognize patterns and make decisions based on data. Natural language processing, or NLP, is a branch of AI that focuses on allowing computers to understand, interpret, and generate human language. It's used in applications like chatbots, translation services, and voice assistants. And finally, the future of programming. The field of programming is constantly evolving, and new technologies are shaping its future, such as quantum computer, no-code, low-code platforms, automated programming, and ethical programming. Quantum computing is a cutting-edge technology that harnesses the properties of quantum mechanics to perform computations exponentially faster than classical computers. And no-code and low-code platforms are tools that allow users to create applications with minimal or no traditional coding. AI-powered systems are being developed that can generate code and software with little human intervention. As AI systems and software houses become more powerful, there is a growing focus on ethical programming. This involves ensuring that technology is developed with consideration for privacy, security, and social impact.